Yes, sir. So previous class, just introduction. This, yes, Java features. Today we should discuss about Java features. Yes, Java features. Sorry. Java documents. Yes, yesterday. Yes, about interpreter and compiler discuss. Yes, 1 second. Java features. They are the Java features. Yes, let me open yesterday document. Yes, see Java features. Yesterday document. Yes, independent platform. Yes, portability, oops language, scalability, security. They are the main features of Java. Yes, yesterday continuation. Yes, main features as below. Yes, independent platform, portability, oops language, scalability, and security. So, what is independent platform and portability? Yes, for this purpose. So, yesterday's class just discussed about basics. Like, yes, about ways we discussed. Yes, about ways discussed. So yesterday about ways discussed. Yes, it's a platform where we can run all the application softwares. About ways discussed. Okay. Yes, about ways discussed. Yes, next about interpreter and compiler discussed. Yes, interpreter compiler main difference exe file. Interpreter does not generate exe file, compiler generates exe file. So this concept is discussed. Okay, fine. Yes, now let us come to Java. Okay. Yes, Java independent platform. So independent platform means yes, independent operating system. Java is a independent. Yes, this topic we should discuss today here. Today topic, yes, these things. Independent platform, portability, oops language, scalability, and security. So Java is independent platform. Java is independent platform. Let us see this. Independent platform. Yes, independent platform. Yes. How Java measure independent platform? This is a question here. Yes, yes, how Java made us independent platform. Okay. Yes, independent platform. Platform means OS. Independent of OS. Independent platform means independent of OS. Okay, independent of OS, right? Yes, how Java made us independent of OS here. Independent platform. Let us see this. So for this purpose, let us see about exe file. So about exe file. About exe file. Okay, about exe file. Yes, here question is what is exe file? What is exe file? So what is exe file? Yes, exe file. Yes, to understand Java independent platform, first of all, you must have exe file knowledge. To understand independent platform, first exe file knowledge. Okay, so what is exe file? Yes, exe file. So what is exe? Yes, exe file is a binary code file. It's a binary code file. Yes, exe file is a binary code file. Yes, it is a system understandable language. Yes, it is a system understandable language. System understandable. Yes, understandable. System understandable language. System understandable language. Okay, exe file is a binary code file. Yes, what is exe? Exe file is a binary code file. It's a system understandable language. Exe file is a binary code file. It's a system understandable language. Just 1 second. Let me show you exe file. Suppose a C program exe file. For example, C program exe file. Yes. Yes, it's a binary code file. It's a system understandable language. So binary code means like binary codes, binary codes, binary codes. Here this is zeros ones format. Binary code zeros ones format. Binary code. It's a zeros ones format. Binary code is a zeros ones format. Binary code zeros ones format. So by yes, exe file, yes, is a binary code file. It's a system understandable language. It's a system understandable language. Okay, fine. Let us log in. Linux. One second. So exe file. Yes. Here exe file. Exe file prepared. Yes, some question for you guys. Okay, just some simple question, very simple question. Suppose exe file prepared on Windows OS. Exe file prepared on Windows OS. Simple question. Exe file prepared on Windows OS. Exe file prepared on Windows OS. Exe file prepared on simple question. Exe file prepared on Windows OS. Can I run on other operating systems here? Other operating systems. Their question here. Can I run on other operating systems here? Their question here. Yes. Exe file prepared. Exe file prepared on Windows OS. Can I run on other operating systems? Their question here. Yes. Other operating systems like Unix or Linux. Can I run it on Linux base? Any idea? Exe file prepared on Windows base. Can I run on Linux base? Yes, you can answer in chat box. Need not to speak here. You can answer in chat box. Here chat box available. You can answer. Just yes or no. Exe file prepared on Windows base. Exe file prepared on Windows base. Can I run on Linux base? Can I run on other operations like Linux or Linux like this? Yes, answer is no. Answer is no. This answer is no. We can't. What's the reason? Answer is no. Reason, yes, exe file is a OS dependent. So exe file is a OS dependent. OS dependent. Exe file is a OS dependent. It's a OS dependent. Exe file is a OS dependent. Reason, exe file is a OS dependent. Okay. Yes. Exe file prepared in Windows base. Can I run on other operations? No, we can't run. Exe file is a OS dependent. So reason exe file is a yes, exe file. Exe file is a OS dependent. Okay, right? Exe file is an OS dependent. Yes, what is it? Why exe file is OS dependent? Why? Immediate question. Why exe file is OS dependent? Yes, why exe file is OS dependent? Yes, let us see. So why exe file is OS dependent? Because what's the reason for this? Why exe file is OS dependent? Okay. Yes, guys, can you hear me clearly? My voice is clear?
Yes, sir.
Clear, right? Okay. Yeah, the thing is, yes, you guys are sometimes going to online or coming to offline. This is asking maybe some issue from my side. Okay. Okay, so exe file is an OS dependent. Why exe file is OS dependent? So why exe file is OS dependent? Okay, see, Java program file is independent of OS. Java program file is independent of OS. But exe file is OS dependent here. Why exe file is OS dependent? This point we should discuss. After that, we will go to Java. After that, we will go to Java. Yes, exe file is a OS dependent. Why? What is the reason for this? So first of all, exe file. So exe file contains what? So exact exe file contains what? So exe file contains what here? Exe file contains what? Exe file contains, see, let me show one practically one exe file. Let's see practical exe file. ls linux is linux base cd, suppose mnr directory ls, yes, 1 second. Yes, remove, suppose start.o file removed here, remove the project exe file. Okay, see, gedit test.c. So this is right. So C program, right? C program. Yes, A equal 10, B equal 20. Into C. C equal to A plus B. Addition, subtraction, and multiplication. So this is C program, right? C program. Yes, C is a compiler-based language. C is a compiler-based language. Compiler-based language. Okay, compiler-based language. No compilation. CC hyphen C. Yes, compile, no error. No error. So test.o object file generated. Now this test.o contains binary code for our C program. Binary code for C program. Yeah, this is C program. The test.o file contains binary code. This whole code converts in binary code. Compiler converts. Compiler converts the source code. Yes, like English language, right? It's English language. Compiler converts. Compiler converts this source code. Compiler converts the source code. Compiler converts. Compiler converts the source codes. Compiler converts this source code to binary codes and write to test.o file. So test.o file contains what? Binary code for this one here. Binary code for your C program. Test.o. Test.o. Test.o file contains, yes, binary code for C program. Test.o. Test.o. Yes, test.o contains binary code for C program. Yes, apart from this, see hash include std IO address. See here, this is header file, right? Header file. So this header file also is having some binary codes. This header file, predefined header file. In this also binary code. This header file binary code. This header file also binary codes. Okay. Yes. Now here. Now. So first ls. So test.o file. It's a binary code for C program. After that, now creating exe cc-o project exe name is project exe here. Test.o, right? Yes. Name of exe project here. Project is the name of exe file. Result exe. Result exe. Yes, enter key. Yes, exe file generated, right? So we got the exe file, project exe file. Yes, we got project exe. Dot slash projects. Dot slash projects. Dot slash project, right? Addition, subtraction, and multiplication. Addition, subtraction, multiplication. So, fine. Fine. Now, what is this exe file? What does it contain exactly here? Yes, see here. What is happening at the time of creation of exe file? See, creating exe file is like this. So here, creation of exe file. Project is the exe file. Yes, C means C language compiler. C language compiler. O means object file. Object file. Yes, object file converting to exe file. How that exe file generating here? Here C language compiler. C language compiler taking binary code for your program. Binary code for your program is test.o file plus binary code of library file. That is header file std IO data header file. Binary code for your C program. Binary code for the header file. Binary code of OS library. OS library also will have some binary codes. OS libraries also will have some binary codes. Okay, by linking all of this in generating exe file. So finally, this project exe file, that project exe file, see that project exe file contains binary code for your C program, binary code for that std header file, means C library, plus binary code for OS library. OS library, that is complete exe file. Okay, that complete exe file. So exe file contains binary code for C program, binary code for header file, binary code for OS library. That's it. So OS library, yes, link to exe file. OS library link to exe file, right? So link to exe file. So OS library is a part of exe file. Okay. So this is exe file here. Yes, exe file contains what? Exe file contains what? Yes. So for example, here, for example, yes, C program exe file. C program exe file exe file prepared. Yes, C program exe file prepared on Windows OS, prepared on Windows OS. Then it contains, it contains first, yes, binary code for C program, 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 plus binary code for C program, plus binary code for C library with that std IO data center for C library, plus binary code for OS library, So OS library, binary code for OS library. Correct? That exe file contains OS library also. Yes, now C program. See, C program exe file prepared on Windows OS. It contains a binary code for C program, binary code for C library, binary code for Windows OS library, here, Windows OS library. Correct? Next, one more example. Suppose C program exe file prepared on Linux OS. So next is first example. Next example. Example 2. Second example. In second example, yes, C program exe file, prepared on Linux base. Then it contains, binary code for C program, binary code for C library, binary code for Linux OS library here, Linux OS library. Okay. Yes, let us take one more example here. One more example. Suppose C++. Let us take C++ here. C++ exe file. C++ program exe file prepared on Linux base. Then it contains binary code for C++ program. Okay. Yes. Next, binary code for C++ library. Like IO Steam data center file. C++ library. Next, binary code for Linux base library. That's it. So OS library is a part of exe file. OS library linked with exe file. It's a statically linking. Okay. See, 1 second. So OS about OS. See here OS. See hardware. Yes, hardware. On top of hardware, OS running it operating system. Yes, on top of hardware, operating system running it. Yes, on top of it, all the application softwares. Yes, all the application softwares. Yes, application software like C, maybe C++. Yes, maybe Java. Yes, Java. Yes, maybe Python. Yes, like it's different application softwares. Okay. Now OS, instead of OS, there is a library here. OS contains library. OS library. It's a collection of functions. It's a collection of input-output functions. Every OS has its own library to communicate between application software and hardware components. So OS using library to communicate between application software and hardware components. Fine. See here, to run all the programs here. This program, maybe C program or C++ or Java, Python here. These are all the programs. Every program. See all these programs. Every program has to link with OS library to communicate with hardware components. That link required components are here. Okay, every program, maybe C program or C++ or Java, Python. Yes, all the programs. Every program has to link with OS library to communicate with hardware components. So before going to run any program here, first of all links with OS library. After linking with OS library, then communicates with the hardware components. Okay. Yes, in case of C language or C++, what happens here? In C and C++, what happens here? C and C++. Okay. Yes, at the time of generating exe file itself. Okay, in C and C++. Okay, in C and C, in C language and C++. Yes, at the time of generating, Yes, at the time of generating exe file, generating exe file. At the time of generating exe file, yes, in C and C++, in C and C++. Okay, in C and C++, in C and C++, at the time of generating exe file, yes, at the time of generating exe file, yes, OS library, yes, OS library, OS library, yes, links, OS library, that OS library, yes, in C and C++, at the time of generating exe file, OS library, yes, links to, yes, in links to exe file, links to exe file. Yes, it is a statically linking here. It is a statically linking, statically linking. It's a statically linking, statically linking. So it's a statical linking, right? Statical linking, statically linking. So at the time of creation of exe file itself, linking this. It's a statical linking here. At the time of creation of exe file itself, linking with exe, yes, linking with exe here. Okay, yes. So at the time of generating exe file, at the time of generating exe file, yes, all the OS library, that OS library links with C program exe file, or C++ exe file. Now exe file is ready to execute. So all the OS libraries linked with exe file. So that exe file contains OS library, exe file contains OS library. Okay, that is about exe file. So what is exactly exe file? Yes, exe file contains binary code for your program, maybe C program or C++ program here. Binary code for library, maybe C or C++ here, and OS library. So exe file contains OS library. Remember this point here. Exe file contains OS library. Correct? Yes. Now here, yes. Let us take some example. Exe file. Suppose Windows based. Yes, Windows based exe file. Windows based exe file. Windows exe. Windows. If it is Windows based exe file here. Suppose if exe file generated on the Windows base here, it's a Windows based exe file. Okay. For example here. For example, yes, Windows based exe file contains yes, Windows based exe file contains Windows based library. Yes, Win library. That Win library. Win library. That's here. Okay. Yes. Test.exe file. Okay, test.exe. Let us take some test.exe file. So test.exe file. Test.exe file. Yes. Prepared. 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 On Windows base. For example, yes, test.exe file. For example, test.exe file. Test.exe file prepared on Windows base. Then it contains. Yes, Windows library here. Windows library here. Windows library. Okay. Now this test.exe file. Yes, when you try to run on different operations, what happens here? Let's see about test.exe. Let us take different platforms here. Different platforms. Let us take different platforms here. Different platforms. Different platforms. Different platforms. Different platforms. Yes, different platforms. Yes, hardware. Yes, hardware. Okay. Yes, hardware. 1 second. Different, suppose hardware. Yes, this computer hardware. Yes, hardware. Hardware. Yes, on top of hardware. Next OS. On top of OS. So first let us take Windows platform. Yes, platform is OS. Yes, it's a Windows OS. Windows OS, right? This Windows OS contains what here? Suppose Windows 10, for example, Windows 10. So Windows 10, it contains what? Windows library, Win library, Win library here, Win library. That Windows OS contains Windows library, right? Okay. Yes. Now test.exe file moving on to Windows OS. Okay. Yes. Now see. Test.exe file prepared Windows base, then it contains Windows library, Okay, correct? Now this test.exe file with with Win library, Okay, all are linked. Test.exe file all are linked with Windows library. Now this test.exe file is placing on Windows base, So this is moving on to Windows base. Just moving on to Windows base, right? Yes, here test.exe file, not test.exe file, test.exe file. Okay, so test.exe file suppose moved on to Windows OS. Now when you try to execute test.exe file, when you try to execute test.exe file here, yes, it makes a call to here Win library. Just makes a call to Windows library here, Win library, test.exe file. See, here test.exe file already linked with Windows library here. Since is linked with Windows library here, when you try to execute test.exe file, now this one it will try to call Windows library. Yes, it will call to Windows library. It will try to call Windows library. Yes, it's available. So the test.exe file, it will try to call Windows library. Yes, it's available. So it's available, right? So using that Windows library, so just the call to Windows library here. Yes, call to Windows library using that communicates with hardware components. That's it. So this is the working of exe file. Okay, same exe file. Let us see another platform here. Another platform. Suppose next platform maybe Linux platform. Yes, let us go to Linux platform here. Linux platform, what happens here? Linux base. So it's Linux base. Here it's a Linux base, Linux library, Linux base, Linux library, Linux library. Okay, how this is working here? Okay, now see test.exe file. Same test.exe file moving on to its right after moving. Yes, when you try to execute test.exe file, when try to execute test.exe file here, now test.exe file try to call to Windows library. Here test.exe file linked with Windows library. Since linked with Windows library here, it will try to call Windows library, but not available. But not this one is not matching, right? So Windows library, right? Here it's a Windows library. Here it's a Windows library, Windows library. Okay, Windows library, but it's a Linux library. So this is not matching here. So test.exe file, it will try to call Windows library on Linux space is not available. It's not available, simply fails. That's it. Okay, so that library is not matching with current base. It fails. Okay, yes, same thing. Let us take another platform. Yes, maybe yes, Unix platform. Let us take Unix space. Unix space. Unix space with Unix library. Unix space is Unix library. Unix space. Now try to run it here. Now this test.exe file same. Yes, it will try to call Windows library, but not available. It's Unix space. That ways is different. That not matching. That library since not match simply fails here. Okay, so exe file is a OS dependent. Exe file is a OS dependent. Exe file is a OS dependent. Reason it contains OS library. Yes, here OS library. Yes, at the time of creating exe file itself, at the time of generating exe file here, at the time of generating exe file in C and C++, at the time of generating exe file, OS library links to exe file. It's a statistical linking. Already linked. Right? Already linked. Okay. Yes, if exe file prepared in Windows OS here, that exe file contains Windows library. So it's a Windows based exe file. Yes, if it is Windows based exe file, it won't run on other operations. It won't run with other operations. So, reason it contains OS library. So why exe file is OS dependent? Simple question is here. So why exe file is yes. See exe file is an OS dependent. First point, exe file is an OS dependent. Okay. Yes, what's the reason here? Reason, yes, since exe file contains OS library. Since exe file contains OS library, yes, it is a OS dependent. It's an OS dependent. That's it here. So that's the reason for this OS dependent. OS dependent. OS dependent. Okay. Since exe file contains OS library, it's a OS dependent. That's it here. It's a OS dependent. Exe. One second. Yes, OS dependent. These are reason for this. So exe file is always OS dependent. Okay, maybe C program exe file, or C++ exe file, or .NET exe file. You take any exe file. Exe file is a OS dependent. Reason it contains OS library. Okay, fine. Now let us come to Java. Java. Yes, Java. What happens here? Let us see about Java here. Java. Okay. So Java. First, compiling Java program. Yes, Java program. Yes, in Java program, what happens here? First, Java program. Yes, source codes. Java program. Yes, source codes. Source code converts to byte codes. Byte codes. Source code converts to byte codes. See, in other cases, source code directly converts to binary code. Just now C program. The source code directly converts to binary code, right? See binary code. You can see the binary code. Binary code 0s1s format. Binary code 0s1 format. 1 second. See project exe file. See it, the project exe file. Open that, you can see. Yes. Some binary formats. All these binary formats. Yes, it's a binary code. 0s1 format. It's a just it's a binary code. Binary code, right? It's a binary code. Binary code, right? See here, 1 second. See except Java, except Java. Yes, in other languages. In other languages, what happens here? Except Java, in other languages. In other languages. In other languages here. So first is source code. First is source code. Source code. First is source code means maybe C program. That English language code. Source code converts into binary codes. Binary code. Source code converts to binary code. This binary code given to processor. So processor, right? Processor. Next, processor taking this one executes and generating output. That's it here. Source code to binary code. Source code to binary code. Source code to binary code. Yes, source code to binary code conversion maybe either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler convert source code to binary code. Okay, right? See here compiler, right? Yes, C programming. Here say compiler CC -C. Yes, test.c, right? Test.c. So compiles. Software project exe file created. Exe file. That exe file is a binary code. That exe file is binary code. So compiler converted the source code to binary code. Source code to binary code. Source code to binary code. That binary code program. Yes, now I'm submitting, right? See, just I'm submitting. So when submitted here, OS will take your exe file. OS taking exe file and submit to processor. Okay, we are giving to OS, right? OS taking our exe file and submit to processor here, right? Submit to processor. Okay. Now source code conversion to byte code, the binary code is given to his processor. So processor will execute the generating output. That's the case of except Java. Except Java, right? Except Java. Okay, suppose in Java, what happens? If it is Java, what happens here? In case of Java, what happens here? Java. In case of Java, so first, a source code converts into binary code, byte codes. Yes, byte codes converts into binary codes. Binary code. There are two stages. Except Java, other cases only one step. Only one step. Source code converts into byte codes here. But when come to Java, what happens here? First is source code converts into byte codes. Byte code to binary codes. Byte code to binary codes. This binary code given to processor. Now given to processor. So processor taking the code, generating output simply. That's it. Generating output simply. Just generating outputs. Okay. Yes. Yes, in Java, this some extra code, one more code, intermediate code introduced here. Intermediate codes. Yes, some intermediate code introduced here. So byte codes. So why byte code introduced in Java? To make the Java is independent platform. So why byte code introduced? So why byte code introduced? Just to make the Java is independent platform. What is byte code? We'll discuss next. Wait, I'll explain very clearly. Now source code to byte code. Who will convert this? Source code to byte code conversion. This is by the compiler. Yep, this is by the compiler. So this is by the compiler. Compiler. This is by the compiler. Right? Source code to byte code by the compiler. Okay, right? Now this byte codes. This byte code converts into binary codes by the interpreter. Java interpreter. Okay, interpreter. Okay, interpreter. Interpreter. Okay. Yes, interpreter. Interpreter. Yes, source code converts into byte codes. This was Java compiler. Yes, byte code to binary code by the interpreter. Okay. After generating binary code, this binary code given to processor giving output, right? Okay, so in Java, there are two things involving. In Java, there are two things involving errors taken by the compiler. If no error, generating bytecode file. That bytecode file is given to interpreter. Okay, so what happens here? See, first is source code. Yes, source code. See source code. For example, test.java file. Test.java file. Test.java file. This test.java file given to Java compiler, Java C, Java C, Java compiler. Okay. Now Java compiler, yes, result file is bytecode file. Just it's a bytecode. It's generating bytecode file. Generating bytecode. Generating bytecode is a test.class file. Test.class. Generating one bytecode file. Test.class file. Right? Test.class. 1 second. Let me show practically. So D drive. With D drive. Yes, test folder is there. CLS. Yes. Here. 1 second. Here they say test.java, for example. Test.java. Yes, notepad. Yes, test.java. Notepad, test.java. Yes, test.java. Yes, nothing empty. This is empty file. Suppose here public class test program. Public class test. Yes, 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 public. Yes, static, public static, void main, yes, brackets, string, brackets, string array fax, starting main method here, yes, system dot, yes, system, yes, caps, system dot out dot, yes, println here is a hello world, hello world, hello world, hello world, hello world, right? Yes, close main, close classes, saved Java program file. Here, see this test.java file. It's a test.java, right? It's a test.java. See notepad, the test.java file. Open that, you can see. See public class test here, public static void main, string area fax, yes, system dot out dot print and hello world. So this Java program, save. Yes, after saving here, now I'm compiling this program here. I'm compiling. See, for understanding purpose, I'm using Notepad. Actually, we'll be discussing with Eclipse. Actually, development Java application development Eclipse. You have to follow Eclipse here. Tomorrow topic Eclipse. Tomorrow we'll discuss about Eclipse here. Eclipse. Java C test.java compiled, no error, not DR. Check it here. C test.class file generated 12:32 p.m. Just not test.class file generated. Test.class. Test.class is a bytecode file. Test.java is a source. Test.class is bytecode. Okay, so test.java. See test source code. Test.java. Yes, Java C, Java compiler. See this. Java C, right? So Java C. See Java C test.java. Test.java taken by Java C compiler generated test.class file. Result is test.class. Test.class, right? Okay, so it's Java C compiler. So Java C compiler taking test.java generated test.class. Now this test.class file, bytecodes. Okay, this is bytecode for test.class file. So this is given to Java interpreter. Java interpreter. So Java interpreter. Yes, Java interpreter converts into binary codes. Test.class file bytecode is given to Java interpreter here. Taking that code, he converts to binary code. Converts to binary code and submit it to processor. Right? Processor. So processor generating output. Right? Now see this. Now, yes, Java test.class file. Now, test.class file. Just I'm submitting for execution. Yes, executed. Java. Yes, you say JVM. As a part of JVM, this is the interpreter. Interpreter taking test.class. Now here's a .class file. Okay, CLS. Yes, DR here. Yes, Java test. Java test, right? Yes, now it's a .class file. Yes, this .class file given to JVM. As a part of JVM, this is a interpreter. The Java interpreter taking test dot class file, converting to binary format, then executing. That's it here. Okay, right? So here this is now here execution by the interpreter. So first it compiled Java C, right? Compiled. After compilation, now execution by the interpreter. Runtime by the interpreter. So interpreter, yes, Java interpreter will execute our Java program. Okay, so here Java, yes, source code to bytecode by the Java compiler. Source code to bytecode by Java compiler. Here errors checking by the compiler. Errors checking by the compiler. If no errors, generating one dot class file means bytecode file. That bytecode file is given to Java interpreter. So interpreter converts bytecode to binary codes and then submit to processor, finally getting outputs. So this is what is happening in the Java, right? So Java depends on Java. Yes, Java depends on both Java depends on both, yes, compiler and interpreter. Compiler and interpreter both here. Compiler and interpreter. Compiler and interpreter. Compiler interpreter. Java depends on both compiler and interpreter. Suppose C program only compiler dependent. Python only interpreter. Okay, C program only compiler. Yes, Python is only interpreter. Okay. Yes. C. Interpreter compiler differences. See this. Yes. Compiler. Yes, yesterday's topic is compiler. Yes. C++, their compiler dependent here. C, HTML, Perl scripting, JavaScript, Python, interpreter dependent. So these are interpreter based languages. These are interpreter based language. These are what? Compiler based. So when come to Java, see Java depends on both the compiler as well as interpreter. Yes, in Java errors checking by the compiler. Java errors checking by the compiler. If no errors, then Java compiler generates one dot class file. If no errors, Java compiler generates dot class file. A dot class file is a bytecode series. Java runtime by the interpreter. Java runtime by the interpreter. Okay. Yes, source code dot Java. Yes, Java C bytecode file interpreter. Okay, then finally output, right? Source code to bytecode to binary code interpreter output, right? Source code conversion to bytecode to binary code to processor. Then finally getting output here. Okay, source code to bytecode by the compiler, bytecode to binary code by the interpreter. So Java depends on both compiler as well as interpreter. That's it here. Okay, Java runtime is the interpreter based. Okay, fine. Now here, yes, now here, not dot class. Yes, about dot class. Let us see about dot class. Just dot class. So what is dot class? So what is dot class for now? Like exe file. What is exe file? Exe file is a binary code file. Exe file is a binary code file here. It contains POS library. Exe file is a binary code file. It contains POS library. So what is dot class? Let us say about what is dot class file. So what is dot class file? So what is dot class file? Yes, what is dot class? Yes, it is a bytecode file. Yes, it's a bytecode file. It's a bytecode file. It's a bytecode file. It's a bytecode file. Okay. Yes, now this dot class file contains what? See here, dot class, right? Dot class. This dot class file contains what? See this dot class file prepared on Windows OS, right? This dot class file prepared on Windows OS. This dot class file prepared on Windows OS, right? This dot class file prepared on Windows OS, right? Even prepared on Windows OS here, it won't contain any OS library. Yes, this dot class file don't have any OS library. Purely Java program. So this dot class file contains a Java program plus Java library. See exe file. What is exe file? C program code plus C++ C library and OS library. Yes, exe file contains what? C program code, next C library and OS library. Yes, but Java dot class file don't have any OS library. It's simply only Java code, Java library. That's it. Java code, Java library. Okay. See exe file. In case of exe file, see exe file here. Exe file. See here. C program exe file. Binary code for C program. Binary code for C library. Binary code for OS library. All these rates. Okay. Yes. If it's same thing, if it is Java, Java dot class. Now let us see Java dot class. So what is dot class file? So what is a bytecode file? That's it, fine. So you can, yes, Java program. Yes, not Java program. Java program dot class file. Java program dot class file. So Java dot class, yes, yes, Java program dot class file is prepared on Linux base. Then it contains here, yes, byte code. It contains byte codes. It contains byte codes for Java program. Okay, next byte code for Java library. Yes, byte code for Java library, byte code for Java library. That's it here. Yes, no voice library. Even prepared on Windows base, no voice library. Okay, yes, dot class file don't have any voice library. Dot class file does not contain voice library here. Okay, dot class file contains only Java program code and yes, Java yes library. That's it here. It's a pure Java program. Yes, dot class is a pure Java program. It's a pure Java program. It's a pure Java program. Yes, no voice library here. Yes, don't have any voice library. Don't have any voice library here. Don't have any voice library here. Voice library. That's it. Purely Java program. See, Java library also developed in Java. See, byte code for Java library. Even Java library also developed in Java. Java library also developed in Java. That means pure Java program. So dot class. So dot class file. Dot class file is a pure Java program. Yes, you don't have any voice library. Don't have any voice library. Right? Okay. Fine. That is dot class. Okay. Right? Dot class purely Java program. No voice library. Okay. Now, how to run this dot class file? So for this, let us take different platforms here. Like exe file. For dot class also, let us take different platforms here. First Windows platform, next Linux, next Unix. Yes, how it's working here? How it's working? Yes. So Windows, right? Yes, now tested dot class. Tested dot class, right? Tested dot class. Test dot class. Okay. Now this tested dot class file placing on Windows base. So first dot class just place on Windows base, right? Placed on Windows base. Okay, not test dot class. Test dot class, right? Test dot class. The test dot class. Test dot class file placed on Windows base, right? Okay, tested dot class file placed on Windows base. Fine. Now here to run this test dot class file, yes, it has to link with voice library, but not linked. Purely Java program. Tested dot class file don't have any voice library. Then how it can execute? See, previously we discussed. See, every program has to link with voice library. Maybe C program or C++ or Java, Python. You take any program. Every program has to link with voice library. Half linking then communicates with hardware, right? Okay. Suppose if it is C and C++, what happens here? At the time of creating exe file itself, linking with voice library. Here that is static linking. But in case of Java, what happens here? It won't links. Okay, at the time of creating dot class file, it won't link here. At the time of creation of dot class file, so when creating dot class file, it won't link. So dot class is a pure Java program. Don't have any voice library. Now dot class placed on Windows base, right? Now this dot class file run here should be run, right? Should run it here. So to run it here, first of all, it has to link with voice library. Okay, to run the dot class file here, okay, it has to run. Okay, yes, it has to run. Yeah, to run it here, this dot class file first of all link with Windows library, then it communicates with hardware. Who will link it? Here dot class file don't have any voice library. Okay, here dot class file don't have any voice library, but it has to link with voice library. Otherwise cannot execute. To execute any program, that has to link with voice library compulsory. But in case of dot class file, it's not linked. It's not linked, right? Yes, support tested dot class file. Moving on to Windows base. After moving on to Windows base here, now this dot class file has to link with Windows library. The dot class file has to link with Windows base library here. Who will link it here? Yes, for this purpose, between dot class and Windows base, one more layer comes to picture here. One more layer. Can you guess it? Anyone? What is that layer here? So who will link it here? Who will link it? So between dot class file and this base, one more layer come to picture. So what is that layer here? Anyone can you guess it? One more layer come to picture. JVM. JVM will come to picture. Java virtual machine. Java virtual machine come to picture here. So Java virtual machine come to picture. Now JVM taking dot class file. So JVM, yeah, JVM taking dot class file here. JVM taking dot class file or links to Windows library. Half linking here, then executes, then generating output, then communicates with hardware here, output device. Communicates with hardware. Communicates with hardware, right? So on Windows space, this JVM. Okay, that JVM on Windows space JVM. So JVM taking dot class file here links with Windows library. So once linked with Windows library, then communicates with the hardware. See, in case of exe file, at the time of generating exe file, OS library linked. So that is static linking. In exe file at the time of generating exe file, library linked. That is static linking. But what happens in Java here? In Java dot class file, yes, no OS library. After moving on to OS here, suppose if it is Windows space here, yes, on Windows space this is JVM, Windows JVM. So Windows JVM taking dot class file links to Windows library means dynamically linking. So before going to run it, just linking and running, right? Dynamical linking. Okay, it's not at the time of creation of dot class file. After moving on to OS, here, running at runtime linking. Okay, if it is exe file, what happens? Compile time. In case of exe file, OS library linked with exe file at compile time only. That is static linking. But the what runtime here? In case of Java runtime, yes, if it is exe file, OS library linking at compile time itself. That is static linking. But when come to Java, that OS library linking at runtime. See, already compiled file. Test.class file already compiled file here. This test.class file don't have any OS library. After moving on to OS here, a JVM taking our test.class file links with OS library. So once linked with OS library, then communicates with the hardware. That's it here. Okay. So this is first platform. Let us take one more platform. So Windows platform. Next, let us take another platform. Suppose same test.class file. Let us place on another platform. Yes, another same test.class file on another platform. Suppose Linux base. Linux platform. Yes, here this is Linux library. So you get JVM. Yes, here are JVM. On Linux base are there is JVM, right? Now here Linux JVM. So on Linux base here, Linux JVM taking test.class file links with Linux library, then communicates with the hardware components. See here on Windows base, Windows JVM links our test.class to Windows library. Same test.class file, okay, on different operations. So test.class file when placed on Windows OS, Windows JVM linking test.class file with Windows library. Same test.class file placing a Linux base. When you placed on Linux base here, Linux JVM taking test.class file, links to Linux library. Okay, depends on OS that link changes. Means dynamically linking, right? Yes, if it is Windows base, linking to Windows library. If it is Linux base, linking to Linux library. Similarly, let us take one more platform. Suppose Unix platform. Same test.class file or Unix. Yes, Unix base. It's Unix base. Yes, Unix base. Right? Yes, Unix library, right? Yes. Now Unix JVM, just Unix JVM taking tested.class file and links to Unix library. See, .class file don't have any OS library. So at runtime, just link to current OS library, then execution. Who will link it here? JVM. So what is happening here? .class file is not a prepared file. After moving on to OS here, depends on OS, then linking text. What is exe file? Already prepared one. So OS dependent. Okay, exe file is already prepared. It carries OS library. But .class file is not a prepared file. It don't have any OS library. Yes, after moving on to OS of .class file, after moving on to OS here, as per current OS linking text. Yes, if it is Windows base, linking to Windows library. Same .class file. Next on Linux, yes, links to Linux library. So same .class file depends on OS that link changing. Link is changing, right? Link is changing. Okay, link is changing, right? Means at runtime linking changing. So it's a dynamic linking. At runtime link is changing here. Okay, it's a dynamic linking here. Suppose exe file. Yes, at the time of creation of exe file itself, linking takes place. It's a fixed one. Okay, same exe file place on different operation, it won't work. It fails. Okay, so if it is exe file, if there is a statically linking. Yes, if it is dot class file, Java program file is a dynamic linking. Dynamic linking, right? Okay, so every OS has its own JVM. Yes, Windows JVM, Linux JVM, Unix JVM. Now doubt is here. JVM, is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. Then how to get JVM? JDK. JDK software you have to install. So once JDK software installed here, you can get JVM here. JDK software. Suppose JDK 9, JDK software. So once JDK software installed here, just automatically getting JVM. Yes, it's a part of JDK. Okay, to get the JVM, JDK should be installed. JDK should be installed. JDK should be installed. Then getting JVM, right? Okay, fine. 1 second. Let me have some water. Now in this here, one important point. Dot class file is independent of OS. Java program is a independent of OS, but JVM is a OS dependent. JVM is a OS dependent. Okay, Java program file. Java program is independent of OS, independent of platform. Okay, platform means OS. Okay, platform is OS. Java program is independent of platform, is independent of OS, but JVM is a OS dependent. So why JVM is OS dependent? Reason, JVM developed in C++. It's a C++ exe. JVM is a C++ exe file. Okay, for Windows space, one JVM developed. For Linux space, another JVM developed. Next Unix space, another JVM. Sunsoft, Java from the Sunsoft. Sunsoft, they have developed different JVMs for different operations. Sunsoft, they have developed. Sunsoft has developed different JVMs for different applications. So JVM for Windows space, JVM for Linux space, JVM for Unix space. Okay, JVM is exe file. So Windows based exe, next Linux based exe, next Unix based exe, right? Yes, here Windows based exe. Okay, so Windows based JVM. This JVM is having knowledge of Windows library. Then it can communicate, right? See this JVM, it's exe file. If it is exe file, it gets what library. Now Windows JVM contains Windows Service Library. Linux JVM contains what Linux library. Yes, Unix JVM contains Unix library because it's exe file. JVM is exe file. JVM is exe. Suppose JVM.exe. That exe contains what? Yes, Windows based exe means it contains Windows library. Yes, now this exe JVM exe file. Yeah, this JVM exe file contains what? Linux based library. Okay, this JVM exe file contains what? Unix based library. That exe file linked with library already here. So the JVM, is linked with Windows library. So JVM linked with Windows library here, it can communicate with Windows space. Yes, now the JVM exe file linked with Linux space, so it can communicate with Linux space here. Next, this JVM exe file linked with Unix library, then communicate direct. So Windows JVM is having knowledge of Windows library because linked with Windows library. Yes, Linux JVM, yes, is having knowledge of Linux library. Reason, it is linked with Linux library. Next, Unix JVM is having knowledge of Unix library. Reason, yes, is linked with Unix library. So here Windows JVM having knowledge of Windows library, so it can link dot class file with Windows library. Okay, Linux JVM is having knowledge of Linux library here, so it can link dot class file to Linux library. Similarly, Unix base. Unix JVM, yes, he is having knowledge of Unix library, it can link with Unix library. That's it here. So the JVM, yes, JVM is having knowledge of OS here. Knowledge of OS here. Because JVM is a OS dependent. Okay, Java program is independent of platform, but JVM is a platform dependent. That's it here. So different JVMs started for different operations. Okay, right? So for this reason here, for Windows first separate JDK have to install. Linux having its own JDK, Unix having its own JDK. So JDK changing from OS to OS. JDK is not same. JDK is not same. JDK is not same. JDK is different for different operations. Okay, one second. Let me show that JDK. Yes, download JDK 1.8 or 1.9 series. JDK. Yes, from the Oracle Corporation. JDK from the Oracle Corporation. You can see Linux JDK. This is JDK for Linux base. Okay, next. Yes, Mac OS. JDK for Mac OS. Next, Solaris OS. JDK for Solaris OS here. JDK for Windows OS. So JDK changing from OS to OS. Reason it contains JVM. JVM is a OS dependent. So for that reason JDK changing. Okay. So this is here Java. Yes, in Java, JVM is the responsible to make the dot class file as independent platform. Okay. So Java JVM is responsible to make the dot class file as independent platform. Okay, fine. Now, what is exe file? What is dot class? What's the difference between these two? That point also we'll discuss. So what is the difference between exe file and dot class file? Same points already discussed, but side by side and comparing. To understanding purpose, I'm comparing. Okay. Yes. Yes, we have discussed about exe file and dot class file. Now comparison of these two. Okay. Yes, exe file, dot class file. See, exe file, it's a binary code. That point already discussed. Dot class a bytecode file. See, here exe file is a binary code file. Dot class a bytecode file. First point. So exe binary code, dot class is bytecodes. Okay. Next, second point. Exe is a system understandable language. Directly system can understand here. What is bytecode? It's JVM understandable. Bytecode is not a system understandable. So bytecode file taken by JVM converts into binary codes. JVM converts bytecode to binary codes. Okay. So bytecode is JVM understandable language. Okay. Yes. Next, exe file. It contains program codes plus software library plus OS library. Yes, it contains program codes plus software library plus OS library. Yes, what is Java? Yes, it's a pure Java program. Dot class and pure Java program. Don't have any OS library. Okay, right? Yes, next. Exe file is a prepared file for specific OS. Exe file is a prepared file for specific OS, but dot class file is not a prepared one. Dot class file is not a prepared one. Okay, right? Yes, next. See OS library. Yes, OS library statically linking with exe file. Yes, OS library dynamically linking here. Dynamically linking with dot class file. Okay, right? See, exe file is already prepared file. Prepared one. Exe file is already prepared one before moving to OS. Already prepared before moving to OS only prepared one here. What is dot class file here? Dot class file is not a prepared file. Dot class file is not a prepared file. After moving on to OS, JVM prepares as per current OS. Okay. See what happened here. Exe file. In case of exe file, here test.exe file. Yes, already prepared. Okay, placing on Windows space and executing directly. Yes, same exe file placed on Linux space fails because already prepared, already linked with Windows library. So test.exe already linked. So placing on Windows directly execution here. Again linking not necessary. Again linking not necessary here. So directly executing that exe file executing directly here. Again linking is not necessary. Means already prepared one. Already prepared. But in case of dot class, what happens here? It's not a prepared. After moving on to OS, links to current OS. After moving on next OS, links to next OS. That's it here. That linking at runtime means not a prepared file. So the dot class file is not a prepared file. So dot class is not a prepared file. After moving on to OS, JVM prepares as per current OS. That's it. Okay. Yes. Next point. See, exe file executes faster than dot class. Reason already prepared file. Okay. Since dot class file is preparing at runtime, Yes, it executes slowly than the exe file. See, exe file is already prepared file. Exe file is already prepared, so directly executes. But dot class file, yes, it has to prepare at runtime. So preparing some time taken here. So Java program executes slower than the C program. So C program executes faster than the Java program. That's it here. Okay, right? Next, to run exe file, application software not required to install. Suppose, for example, here demo. Yes, here this is a project exe, right? This project exe. Yes, in this on this Linux where C software already installed. C software is there. Using that C software, that exe developed. Same exe file placing in other Linux space. See, one more Linux. Suppose in my system there are five or six systems are there. Same exe place in other Linux space. Direct will execute. OS matching directly executes. C software not necessary. Okay. See here on this Linux space, C software already installed. Using C software, yes, application development completed. Exe developed. Now exe is ready. Now this exe directly can place on any Linux space, directly can execute. C software not required. To run the exe file, that application software not necessary. To run C program exe file, C software not necessary. To run C++ exe file, C++ software not necessary. But to run Java, Java software required. To run Java software required. Reason JVM required, right? Okay. To run dot class file, JDK should be installed on the OS. Why JDK? JVM purpose. So this is difference between exe file and dot class file. So exe file is OS dependent. Reason it contains OS library. Dot class file is independent of OS. Reason it don't have OS library. Simple point here. Simple points. Since exe file contains OS library, it's a OS dependent. OS dependent. So why exe file is OS dependent? Reason it contains OS library, so it's a OS dependent. Yes, dot class file don't have any OS library. It's a OS independent. That's it here. Okay. Not only Java program. Take anyone, any program which is having OS library, it's a OS dependent. Okay. Any program already linked with OS library, that is OS dependent. C OS dependent, C++ OS dependent, .NET OS dependent because already linked with OS library. Okay. Next, similarly Python. Let us take Python. In case of Python, yes, in case of Python also. See, in case of Python also here, Python. Yes, in case of Python, see Python. In case of Python also, see Python also. Python program file not linked with OS library. Python script also links to OS at runtime here. Python script file also links to OS at runtime. So Python is also independent of OS. Python is not OS dependent. Python also independent of OS. Reason Python file don't have any OS library, it's independent of OS. Okay, so this is about yes, independent platform. That's it. So how Java made us independent platform is like this. That's it. Okay, right? Yes, next. How to develop Java applications. Okay, so this topic tomorrow we'll discuss. Tomorrow, Java installation, Eclipse installation. After how to develop the first program we'll discuss. Java installation steps and Eclipse installation steps. So what are the steps to develop the application Eclipse? That point we'll discuss tomorrow. Yes, that's all. Yes, that's all for today. Tomorrow we'll continue for Java installation. Okay. Yes, any doubts? Yes, guys, any doubts? Yes, any doubts for today class? Yes, just you go through the document here. Just you see the okay, read the document, you can understand everything here. Document I have prepared very clearly. Yes, the exe file and all this. Very clear documents. Okay. Yeah, that's all for today. I think no doubts, right? Yes, if no doubts, let us wind up session for today. Right? So thank you guys. See you tomorrow. Tomorrow Java installation and Eclipse setup. Right, thank you.